Hello everybody, welcome back. In this video we're going to be talking about different forms of linear equations, a little bit of graphing, how to construct them, and a little bit of application to them as well. To start off, there are three main forms. Slope-intercept, y equals mx plus b. M is the slope, b is the y-intercept. Point-slope form, we have m for slope again, and then we have a specific point, x1, y1. Standard form doesn't, at first glance, does not look to be useful as far as graphing or identifying parts. It's just more of a formalized way to write a linear equation, ax plus by equals c, where a, b, and c are whole numbers. And notice they all have in common variable y and variable x. So let's start off here. Which graph represents the equation y equals 2/3 x minus 2? Well, this is in slope-intercept form. So let me match it up here with the formula. Y equals mx plus b. b is the y-intercept, -2. It means it crosses the y-axis at -2. And the slope is 2/3. And just a little explanation of how slope works. Slope is always written as a fraction. Top number tells you how much you go up or down. Bottom number is whether you go left or right. Up is positive, down's negative. Right positive, left negative. So this is a positive 2/3. It means to find another point on the line you would go up 2 and right 3. Well, looking at all four of these options here, we need to pick a line where we cross the y-axis at -2, and the only one that seems to is this one right here, and we will mark that is right there at -2. There's our y-intercept. And then following the slope, if we go up 2 and to the right 3, notice we are another point on the line. And we can keep doing that to infinity, up 2, right 3, up 2, right 3. So for this problem, our graph appears right here, y-intercept of -2 and slope of up 2, right 3. All right, let's look at another one here. We're just going to create an equation. What is the equation of the graph whose slope is 2/3 and y-intercept is -2? All right, similar to the one before. In fact, it may be the same problem, but let's go through the steps here. If we're going to tell you the slope and the y-intercept, y equals mx plus b. All right, I'm going to put -2 where the b is, and I'll put a 2/3 where the x is, and y equals that. So if we give you the slope and we give you a y-intercept, we can create the equation in what's called slope-intercept form. All right, we're going to use slope-intercept form here to talk about a application problem, y equals mx plus b. Yes, the y-intercept is b, but in story problems, we're now going to think of that as a starting amount. Or the initial amount, starting amount, initial amount. And the slope is m number, usually written as a fraction. But in story problems, we want to think of that as a rate. How fast something is changing, how fast it's increasing, how fast it's decreasing. So in this problem, there is 1 inch of water in a pool. The water level is increasing at a rate of 0.75 inches per minute. What's a linear equation to represent the total depth of the water in inches after x minutes? All right, so let's get this set up. Starting out, there was 1 inch of water in the pool, and that's the y-intercept or starting amount. And then the increasing at a rate of 0.75, that would be where the slope is, or the rate, 0.75. Notice this equation is in slope-intercept form. And the rate at which the water is changing is right here next to the x, 0.75. It started out. Given this equation, we can determine how much the water level of the pool at any point in time, at any minute. We can plug in 20 for x, simplify it, figure out what the water level is. We can plug in 30 minutes, 40 minutes, whatever number we want. We can determine how high the water is, y, by the number of minutes x that have passed. All right, now we're going to switch gears a little bit to point slope form. Yeah, we're going to need point slope form. Let me write that formula once again. Y minus y1 equals m x minus x1. All right, so in this formula, we have a couple of items. We have the slope, which is m, and we see that right here, the slope of 2, so we know 2 will go there. And we also have the points x and y, and let's call this x and y, and given that it's a specific point, we're going to label it x sub 1, y sub 1, x1, y1 if you want. And that tells us where things go in the formula. Here's the y1, here's the x1. All right, so the 9 is going to go here. The 5 will go here. And then the slope, which is 2, is going to go right here, and everything else, parentheses, variables, stay put. And there's our equal sign as well. So our equation then, y minus 9 equals 2, parentheses, x minus 5. And if you just look here, it looks like a minus 9, looks like a minus 5 with the symbol. That's always going to be the case. 5 and 9 positive up here as the actual coordinate points, but looking in the formula, it looks like a minus 9 and a minus 5. That's always going to happen. We're going to have the opposite sign. Say this was a minus 5 and a minus 9 up here. This would be y plus 9. This would be y plus 5. All right, that brings us to our last one that kind of brings all of them together, all the concepts here together. A line passes through -1, 7, and 210. What's the equation of line in standard form? There's 3 kind of parts to this. And the first part is use the slope formula to figure out the slope of the line passing through those 2 points. In the slope formula, y2 minus y1 all over x2 minus x1. And then we'll go back up top here and we will label these points x and y, but we see we have to differentiate them. We have to call one x1, y1 and the other x2, y2. Now we know to plug them in the right corresponding parts of the formula. 10 goes in for y2, 7 goes in for y1, 2 goes in for x2, -1 goes in for x1. 10 minus 7 is 3. 2 minus -1 is 3. We have a slope of 1. All right, so this is the first part. Second part of solving this, we'll put it in point slope form just to get, and the reason we're choosing point slope form is because we have 2 bits of information. We have a slope and we have a choice of one of 2 points. So here's point slope form. I want to plug in what I know. Y will stay put, parentheses, and the x, I'm going to put 1 in for m, right? And then I will put in x1, y1. y1 is 7, y minus 7. And then -1, x minus -1, really written as x plus 1. So now we're in point slope form. If the question said write it in point slope form, we would be done. However, we need to write it in standard form. And standard form, if you remember, is ax plus by equals c. Notice the x's and y's are together on the left side of the equation. To make this happen, we're going to distribute the 1, and that's going to give us y minus 7 equals x plus 1. We're going to subtract x from both sides. And then we're also going to add the 7 to both sides. That'll move the x to the left and the 7 to the right, giving us all numbers on the right side, variables on the left. We're going to have -x plus y equals 8. And notice we are now in standard form, where the a number is a -1, the b could be a +1 there, and c is 8. And that's how we can create a standard form equation, line passing through these 2 points. So 3 parts here: find the slope, plug it into this point slope form, and then convert it to standard form. Thank you for watching. Hopefully this clarifies different forms of linear equations.